Okay. Today we study chapter 7. Chapter 7 is about the computation of derivative and integrals. Yeah, derivative at some point C and integral. Yeah. About function f, we don't have a formula for function f. We only have some function values. So the information about function f is very limited. So with limited information, how to accurately compute derivative and integral. Okay. Today I developed some formulas for derivative. The tool is Taylor expansion. Okay, Taylor expansion. Okay. Okay. First formula, number 1. I want to compare derivative at x. X is fixed. Okay. Any point, any x, any x. Okay, now let me expand x plus h. Yeah, in this expression, x is fixed. H can change. Now let me expand this by Taylor theorem. Okay, Taylor theorem. So first term, f of x. Second term, 1/1 factorial derivative at x, then times h, right? Times h. For the first formula, 2 terms enough. Then add error term, 1/2 factorial second derivative at some point psi times h squared. What is psi? Psi is a point between where psi is a point between x and x plus h. I want to compute this. Okay. Compute derivative. Yeah. I want this guy. Now I solve the equation for derivative. Okay. Now from here, we have move f of x to left side and then divide the equation by h. Solve the equation for derivative. Then we have is equal to f of x plus h minus f of x. Divide the equation by h. So divide the equation by h. So over h. Minus. F of x, move it to left. And also the error, move it to the left. Then divided by h. So this is 2 factorial is 2 sine h. Now I drop the error term. Then I have the first formula to compute derivative. Drop the error term. Yeah. drop the error. Then we have derivative can be approximated by this quotient. Over H. Because the error, the book give a name to this error. Call it this error log round of error. Log round of error, right? This is a given name. Truncation error. Call it truncation error. Because we truncate the equation to obtain this formula. Truncation error, log round of error. Clearly, by recall the BO and little o rotation, actually, this is a BO order H. As H approaches 0. So when H is small in the neighborhood of 0, this is bounded by H from above in absolute value. So order H. So actually, this formula, we call it, how accurate this formula? We call it order 1 formula. Because the power of H is 1. If the power of H is 2, recall the formula, order 2 formula. If the power here is 3, order 3 formula. So this is an order 1 formula, not very accurate, right? Order is higher, the approximation is better. Okay, right. This is order 1 formula. Say how to use this formula. Let me show you one example. Example, consider the function cosine. I want to compute derivative at pi over 2 by this formula. Okay, x is pi over 2. How about h? With h be 0.01. Okay. The exact value of derivative is easy to get, right? Exact value solution. Exact value of the derivative. Let me see. Derivative of the function is f negative sine. Derivative. So exact value is negative sine pi over 4. Exact value. It is negative square root of 2 over 2. 7071. Exact value. Now, I use this formula to get an approximation. Okay. Let me give a formula. This formula a name. Say formula 1. Okay. Now by formula 1. by formula 1. Derivative roughly is function value at pi over 4 plus h. H is a 0.01 minus function value at pi over 4 then over h 0.01. This is a function is cosine. So cosine pi over 4 plus 0.01 minus cosine pi over 4 over 0.01. Okay. Calculator. It is negative 0.710. Yeah, 51. Exact value. Approximation. Yeah. They're close. How close? Compute the error term. How close? Okay. Error term. Error term. Error. Okay. Error is what? Negative h over 2. Second derivative. Evaluate at some point. Sine. Sine. We don't know. Okay. We only know sine is between x and x plus h. Okay. Take derivative twice on the function. Once is negative sine. Derivative again, negative cosine. So this is a negative cosine. So this is a h over 2 cosine. Okay, cosine of sine. Okay. H. Okay, now the error. Usually take absolute value. Absolute value of the error is absolute value cosine. So h 0.01 over 2. So this 0.01 over 2, 0.01. 5, right? 0.01. Okay. Absolute value cosine. Yeah. All right. Let me see. Sine is between x and x plus h. Yeah. Sine where? Sine is between x and x plus h. X pi over 4 is x. Pi over 4 and then h 0.01. I know sine between these two numbers. Okay. Recall the graph of cosine. Graph of cosine is decreasing. Okay, between 0 and pi over 2, the graph is decreasing. So cosine of sine is less than, okay, this is a log greater than cosine of pi over 4. Yeah, log greater than. The graph of cosine, yeah, graph of cosine, yeah. 0 pi over 2, the graph, you see, decreasing. Cosine, the graph is decreasing. So yeah, this number log greater than this number. Now this is a what? Calculator. That is here. Yeah. 0.00 3, 5, 3, 5. So this is the error. Of course, you can directly this number exact number minus the approximation to get the error. But you can use the error term, okay, error term to get the error. This formula, first formula, not accurate. Just an order 1 formula. Yeah, this is an order 1. Order h to 1. Okay, order 1 formula. Now, order 2 formula. Let me develop order 2 formula, a better formula. Okay, better formula. Order 2. Still use Taylor expansions. Formula number 2. Okay. I want to compare derivative at some point x. Now expand function at x plus h. The formula is, the equation is this. 1 over 1 factorial, okay, derivative times h plus 1/2 second derivative x h squared. Yeah, I want to obtain order 2 formula, so I need more terms in the expansion. Then this is a 1 over 3 factorial. The derivative evaluate at some point psi 1 h to the. Yeah. I also expand x minus h. Yeah, x minus h. It is just replace h by negative h. Negative h, so minus 1. Yeah, minus 1 over 3. Psi 2 h to the. Okay. Where psi 1 is between x and x plus h, psi 1. Psi 2. Psi 2 is between x minus h and x. So actually, psi 1 and psi 2 is in this interval. Yeah. 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 Psi 1 between x and x plus h. Psi 2 between these. In short, psi 1, psi 2 is in this interval. Hey, now let me get order 2 formula. Okay. How about let me name this equation number 2, and this is equation number 3. Equation number 3. Now, let me see. I want this guy. Okay. No. I want this. Okay. I want this guy. Okay. I want this guy. So, how about equation 2 minus equation 3? see what will happen. Left hand side is f x plus h minus f x minus h. Yeah, left side. Now, right side. Equation 2 minus equation 3. So, f of x is cancelled, right? You agree? Yeah, this is cancel, right? Cancel out. And this second term minus second term, it is 2f derivative times h. Third term minus third term, cancel out. Cancel, right? You agree? 3 factorial is 6. So this term minus this term, you agree? It is plus 1 over 6 times f, the third derivative at psi 1 plus the derivative at psi 2, then times h to the third, right? Okay. Hey, this is what I want. Let me solve the equation for this guy again. Move the other term to left hand side, then divide the equation by 2h. Right. So we have derivative at x is f x plus h minus f x minus h, then over 2h. Then minus 1 over 12 h squared, right? You get I think so.
It should be 1 because 1 over 3 plus 1 over 3.
This minus this. Yeah. So plus, okay, plus. Hey, let me combine these two terms. Okay, so this is let me write this term as x plus h minus f x h over 2h. Here, 1 over 6 f the derivative 1 plus f, yeah, then over 2 times h squared. Now, let me, I want to combine these two terms together. Okay, let me draw. Suppose this curve is the graph of x. F the derivative, right? Suppose the graph of this is this, okay? Suppose x is here, x minus h here, x plus h here. Sine 1 between x and x plus h. See, sine 1. Sine 2, sine 2. Sine 2. So function value at sine 1. Function value at sine 2. This high. Now take average on the height. So average, yeah, this height plus this height, take average about here. This is a function value at psi 1 plus function value at psi 2. Average about here, right? Yeah, about here. Yeah. This height is function value at psi 2. This is a function value at psi 1. Take average. So average is about in between. Okay, in between. Yeah. So you see, I can always there is a point psi 3. So that function value at psi 3 is equal to the average. So let me. This is a f x plus h minus f x minus h over 2h minus 1 over 6 derivative at psi 3 times h squared, right? What is psi 3? I don't know. But I know psi 3. I know psi 3 is in this interval. Yeah. Error term. How to call this error term? Truncation error. Yeah. Again, this is a truncation error. I'm going to truncate the equation. Truncation error. Truncation error. Truncation error. This is not round-off error. Okay, round-off error appear in computation. Yeah. This is a truncation error. Now let me drop the error to get a second formula. Okay. Second formula. Here. Yeah. Second formula. So we have formula. Roughly is f x plus h minus f x minus h. Then over 2h. Second formula to compare derivative. How good this formula? Order 2 formula because of error. It is order BO h squared. Yeah. Order 2. This is an order 2 formula. Order 2 formula. Now let me show you one example. To compare order 2 formula and order 1 formula. Order 1 formula, I have erased. Let me see. Order 1 formula. Yeah. Order 1 formula. Yeah. This is an order 1 formula. This is an order 1 formula. Order 1 formula. Now, take a look at one example. I compare these 2 formulas. Yeah. Example number 2. I use a 64-bit computer standard. The computers in the office here all 64-bit computers. Standard. Use a 64-bit computer to approximate derivative and derivative. Okay. Where? What is the function? The function is r tangent x. I want to compare r tangent x derivative at which point? At the point is square root of 3. 2 square root of 3. Yeah. It's easy to get the exact value of this derivative. Okay. Exact value. Easy to get. Exact value is derivative at square root of 2. Arctangent. Arctangent derivative is arctangent derivative. Then after we compute derivative, plug in square root of 2. So 1 over 1 plus x squared. Then plug in square root of 2. So exact value is 1/3. 1/3. Now, two formulas there. Okay. Now let me make a table. Compare. Okay. Compare. Here. Okay. First column, K. Second column, H. Yeah. In this formula, X is square root of 2. H. I divide H is a 1 over 2 to K. Okay. 2 to K. Right. Now, derivative by computed by order 1 formula. How about let me give a name? Okay, give a name. Order 1 formula 1, 2, 3. 4. Say number 4. Number 5. Okay, number 5 is order 2. Okay, by 4. Yeah, derivative. Derivative compute by 5. Order 2. Yeah. Order 2. Now, I pick 2 for K. When K is 2, H is a 1 over 4 on 25. Yeah. On 25. Theoretically, as H approaches 0, the right side will approach the left side. Theoretical. More and more accurate as H is decreasing. Right, now, by order 1 formula, what I get is 29, 76, 40, 62. Yeah. Order 2 formula. 33, 71, 93, 88. Yeah, better, right? Better. Closer to 1/3. Right? What is 1/3? 1/3 is a 0.333. Order 2, better. Closer. How about K is 10? Yeah, K is 10. Then H is small. It is a 0.9765 times 10 to negative 3. Small, but not very small. Okay. Order 1 formula, then I get 0.333. 1, 7, 9, 9, 44. Okay. Yeah, this is order 1 formula. Order 2 formula 1. Free. How many free? 7 frees. Then now, order 2 formula. Okay. In practice, this is just example, okay? Example, we have a formula for function n. In practice, no formula. 18. K is 18. K is 18. 18. What is h? 38. 15 times 10 to negative 5. Now this time h is small. What is order 1 formula? What you get? Okay. Free. 5 free. 2, 7. Let me write more digits. Yeah, this is the order 1. How about order 2? Wow, order 2. How many frees? 10 frees. Free. 10, okay? Free. And then 4 free. 0, 3, 5. All the 2 formula converge very fast. Next section, this is section 7.1. Next section, teach you how to develop a formula of any order. Superpower, okay? Very powerful, super powerful. This is order 2. Okay, now continue to decrease h. How about 40? 40. 40. Wow, h is 10 to negative 12. Wow, very close to machine error. 10 to negative 16. But when h is too close to 0, now one of errors start to dominate the computation, start to ruin the computation. Now the result becomes not accurate. Let me see. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Okay, yeah. Here. On 3. 7, 4, 0, 23. 43, 75, 0. Okay. This is order 1. Order 2. On 3. 7, 4, 0, 23. 43, 75, 0. Yeah, h cannot be too small. If too small, then run of errors. Okay. Take effect on your computation. Yeah. Okay. How about 54? 54. This is h is 51. 10 to negative 16. Now, order 1 formula give you 0 and 0. Yeah. Completely lost accuracy. This is order 1 and order 2 formulas for first derivative. Take derivative once. Now, how about second derivative? Formula for second derivative. Yeah. Now, formula number 3. formula number 3. I want to compute second derivative. Yeah. Again, I use Taylor expansions. Okay, Taylor expansions. Here, expand x plus h Taylor expansion. Second derivative, then plus x to the third over 3 factorial. Yeah. And then 1, 2, 3, 4, 4 terms. I need 4 terms. And then error term. Take derivative 4 times, evaluate at some point psi, where psi 1 is between x and x plus h. I also expand x minus h. Yeah. This is easy. Just replace h by negative h here. Okay. So again, minus plus minus, then error term plus 4, then evaluate at psi 2. What is psi 2? I don't know. I just know between x minus h and x. I just know. Now again, give names to the equation. Give names to the equation. Let me call this 4, 5, 6. Okay, equation 6 and 7. 7. Okay, 7. What I want is this guy. Okay, now this time I want this guy. Okay, I want this. I want this. Okay, I want this. Okay. Now what to do? This time, ah, 6 plus 7. Okay, this time. Okay, yeah. Equation 6 plus equation 7. Okay. Left hand side is f x plus h plus f x minus h. Yeah, left side. F of x plus f of x to f of x. This term is cancelled. 2 factorial is 2. So this plus this is h squared second derivative. How about the next term? Next term, cancel. Then error term. 4 factorial is 24. Yeah, error term. Plus error term. 1/24 f4 psi 1 plus f4 psi 2. Then h to the 4. 对不对？ just like before. Okay, let me combine these two terms together. Yeah, let me write this as 24. Let me move 2. Okay, here 2. Then this is 12. Right, 12 here becomes 12. So average. This is a fourth derivative. Evaluate at some point psi free. What is psi free? Yeah, psi free is in x minus h, x plus h. Very simple. Okay. Right. So we have f x plus h plus f x minus h is 2f plus h squared second derivative plus 1/12 fourth derivative evaluate at some point psi free times h to the 4. Okay, now I want this guy. Okay, solve the equation for the guy. Okay, here f second derivative is equal to move this to left side minus 2f. Then over divide the equation by h squared minus f, yeah, psi free h squared. Truncation error. Truncation error. Truncation error is order 2. Yeah, this is a order 2. Drop the truncation error. We have a formula to compute second derivative. Yeah, drop. Then we have formula to compute second derivative. The second derivative is order 2 derivative. In a similar way, you can develop formulas to compute the third derivative, the fourth derivative, and so on. This is a develop differentiation formulas from Taylor expansion. Okay. Hey,
Did you mean to write psi 2 for between x minus h and x? Right at the bottom, psi 4.
psi 4 is between this and this.
What is psi 4?
Psi 2. Psi 2. Not psi 4. Psi 2. Yeah, psi 2. Okay, then see you Monday. Monday we study 7.2. 7.2, I present a method. The method tells you how to develop a formula of any order that you want. Okay. Yeah, see you Monday.